All right, here we go. So this was the second paper that I gave you guys yesterday, okay? So let's take a look at number 1 there, okay? So you'll see here it just says to factor by grouping, okay, and just factor each completely, it says, so as much as we can. So if you look here, there's already a factor in front here, right? We already have the 5 factored out from the a plus b, okay? And we also have an x factored out from this a plus b grouping. So what we've got then is kind of like, we're already kind of like halfway through the problem here, and now we can see that in this pair and in this pair right here, we have the same a plus b set of terms.
This is just for later. I'm just handing this back.
Okay, that's fine. That's fine. Yeah. Okay.
There's no grade on it or anything.
So the a plus b there, right? That's in common to both things. So it is a common factor of this and this. So we're going to factor it out. We're going to pull it out front here, kind of like undistribute it, if you might want to think of it that way. Okay, like this. And so we'll have a plus b, parentheses, and then if I take a plus b out of this, what will be left behind?
5.
A 5. And then, yeah, the plus x there, exactly right. And that's it. We're done. That's all you have to do there for number 1. Okay, Carson, is that making some sense? Okay. Good. Good. And then you're done with the clipboard, right?
Yes, I am. Oh, I didn't have a couple people that I didn't have papers for a couple people. I don't know what they
Wait, so
Catherine wasn't here, so she might have it.
wait, it's not this paper. She's getting a different paper.
Correct. There's the first one that we had from yesterday. She's passing those back now. Yes, Alex. Okay, so do you see here that we're this is like 2 terms we're adding together here. We have this plus this. Okay? So when we factor using a greatest common factor, we're looking for what these 2 terms here, Alex, have in common. They both have an a plus b. Right? So we can divide or factor out that a plus b like here. Right? So a plus b, we're going to take out the a plus b. If I factor an a plus b out of this, what will be left here? If I factor it out, it's gone now. What's left?
What are you factoring out?
I'm factoring out a plus b. If I factor out a plus b, what is left? What else is there besides the a plus b? The 5. There it is. And if I factor out the a plus b from this term, what's going to be left? The x. 5 plus x. Okay? So you see what I did here is we took out this a plus b that was in common, that was shared by both of these. Pull it out front. What's left behind is the 5 plus x, which is this. Okay? This is the exact opposite of what we were doing right here in number 2. Number 2, we had 2 things. We distributed to the x and to the 2, so we got this, and then we distributed one more time to get this. Now we are going backwards from this. Okay, that's the idea here, Alex. We're going backwards. All right. Let's go to number 2 here. Okay?
Excuse me. The paper I'm handing back, I just checked number 4. It was your homework from 2 nights ago, from the night before last. That's all I did. I just looked to see if you did it. Like Mr. Witt comes around and gives you a little mark in the book. That's all that is.
Okay. Just the homework we were checking there. All right. So, and it's the same. Those questions Mrs. Mulcahy is handing back right now are the same as the ones that we're doing on this paper. They're very similar, I should say. Okay? Very similar kind of questions. All right. So we look at this one. Okay? Again, you can see it's already got some factoring done here for us. So it's already factored somewhat. So we just have to look again at the 2 terms here. So Alex, you want to try this one? So what do you see in common between these 2 terms here? They both have x, not just x's, they have what?
4.
X plus 4s. They're all together one thing, x plus 4. So from this, we're going to take out this x plus 4. Okay, and we're also going to take out this x plus 4 as well. So they both come out front, okay, like so. All right? And so then what's left behind? If I take an x plus 4 out of this, Alex, what's left behind?
X plus 4.
If I take it out, what's left behind? An x. If I take an x plus 4 out of this, what's left behind? Minus 3. Okay, and so there is...
So let's say there was, instead of the 2x plus 4s, there was a b plus a.
Okay, so if you had like x times b plus a like this,
No, and then you also had negative 3x plus 4.
minus 3x plus 4 like this.
Yeah, how would you do that?
Right, so are these the same?
No.
So then you can't factor those out.
So what do you say?
So you're done. That's the best you can do.
Like, but if they give you one like that, you just leave it in.
You would say this is as fact like so this remember this is part of factoring by grouping. So factoring by grouping does not work. It doesn't factor. So you might say something like this: does not factor. Okay? Because you're right. It doesn't factor. There's nothing in common.
But if I try to do one on the test because I forget, does that become wrong? Or will there be any questions that I just have something like that on the test?
There might be. That's a good question. So we'll keep an eye out for that in the review. But you should be able to tell when you can and when you cannot factor. You should be able to determine that. Yes. Okay. But 90% of the questions we do, Alex, 99% of the questions we do will factor in some way, because right now we're just interested in you getting the skill of factoring down, and so it kind of slows things down some when we throw a bunch at you that don't factor at all, because then you're like going to spend a bunch of time trying to figure out does it not factor. But we might throw a few at you, so I'll highlight those when we come across it. Okay. All right. Let's look here at number 3. Okay, and let's go to Mark. Mark right here, okay, again, we've already factored some, right? They already pulled out this GC of x here. What's in common now between these two terms?
2. Or
Not
negative 2.
the x minus 2, right? The whole quantity here, x minus 2. So we'll pull out an x minus 2. If I take an x minus 2 out of this, Mark, what's going to be left behind?
The x.
The x. And if I pull an x minus 2 out of here, what's going to be left behind? What number is in front right here that I don't have written?
1.
A 1. So we're going to put a plus 1. Okay, and then that is factored completely there. Okay, there's nothing else we can factor out. All right, now let's look at number 4. Now number 4 is different. Okay, how is number 4 different than 1, 2, and 3 here?
It's not grouped by parentheses.
Yeah, it's not grouped at all yet. Okay, not only is it not grouped, but 1, 2, and 3 already had some factoring done for us, right? Like they already pulled out the 5 and the x here. They already pulled out an x and a minus 3. They already pulled out an x and a 1 here. Here, it's not been grouped, as Sky said, and there's nothing been factored out yet. But the good news about factoring by grouping is that we're going to choose, we can just kind of like be able to look at it, and we'll just kind of like group the first 2, and we'll group the second 2 together. Okay, so we're going to have to put in the little groupings ourselves there. Okay. Okay, so let's take a look here now. So let's go to Matt. So Matt T. From this first group here, Matt, is there anything we can factor out? Okay, a 2 and a y. Very good. So you did it all at once. Perfect. If I take 2y out of 2y squared, what's going to be left behind? 1y. Or just y. And if I take a 2y out of 4y, what's going to be left behind? 2. Just 2. Yeah, okay. Okay. So far, so good. We following along all right? Question, anything? Alex, makes sense so far? Where this came from? I took a 2 and a y out of both these terms, and that's what's left behind. So far, so good? You can just put y if you want to.
Why do we do this, though? What does this do?
We're going to be using it to factor quadratics.
Or do they use it in the real world?
It's not, but guess what? You have to pass high school to graduate. Or you have to pass this class to graduate high school.
You don't use
So.
this in the real world?
Not really, no.
Like for anything?
For nothing. You guys aren't going to be using it, no. Most likely, no.
Who does use it?
Who does use this? Yeah, high school math teachers do.
You know what? It's like a puzzle. Do you guys do puzzles? That exercise.
That's not, yeah, man, that's not, they don't care about puzzles.
But I mean, just break. Okay, you're missing my point. The thing is that it kind of makes you think about things. Excuse me. Never mind. You know what? So sorry.
Yeah.
That was annoying. I was just looking for my paper.
Oh, your paper? You're the answer key? Is that right there? Shh. Okay, so Alex, I seriously, 90% of you guys will never use this again in your life. Okay, so what I would suggest to you is when you get a voting age, is you make sure you if you really think this is a bad idea, remember this. Okay, 5 years. 4 years, 3 years, 2 years, however many, how long it takes for you to start voting, okay? Wait for that point, and then, I would say start making changes, because I agree. This is kind of silly. We have to learn this. And it's silly that it's a high school requirement.
I voted for it then.
So it's more of like a matter of like the people that are voted for, they're the ones that decide that this is important or not, kind of thing. So I would suggest that you try and find people that don't.
Substitute this for though.
Thank.
What else can we learn?
So I mean, I would say there's a class in this school that we teach called contemporary math, where people learn how to like balance a checkbook and write a budget and plan for a vacation or save or mortgages and stuff like that, or do their taxes. Much more applicable. This, I mean, I'll say this though too, Alex. Again, if you're very curious, right? Why do people do weight training? Right? So, for example, for sports, you go into the weight room, right, for track and field, and the idea is you go and lift weights to help you be faster. But you're not running. You're sitting there and you're picking up weights and you're putting them back down, right? But you're doing certain exercises that will then help you and translate into, your running or whatever you happen to do. So, similarly here, right, these are not maybe going to directly affect your life, but you're learning how to learn. And that's more important because you're going to be learning for the rest of your life, or at least hopefully you will be, right? And so, right, this particular skill that we're doing right now is not necessarily going to be used, later in life. The question, but this, you're not really asking that question. You're really just telling me, Mr. Wood, this is hard. I don't want to feel like I have to do this.
No, I'll do it.
But I mean, I get it. But I'm just saying, not everything in life is going to be super fun and exciting either. Sometimes you just got to.
Asking how it could apply to
Right.
the real world.
I don't really have a good answer for that.
Okay. That's fine.
All right. So anyway, looking at the second group here. All right, Matt, you want to continue with us here? What else can we take out of this second group?
You take out a
3. Anything else? You want to do it piece by piece? Okay, a 3 and an x. Yeah, so we can take out both a 3 and an x there. So if I divide 6x by 3x, I'm left with a 2. If I divide 3x by that, I'm left with y. Okay? Now, let's look at what's left over here. So now we look like 1, 2, and 3, right? Now we look like the questions 1, 2, and 3 where things were factored out, right? Things were already factored out for us in 1, 2, and 3. Now number 4 looks like that too. We have things factored out. Okay? In 1, 2, and 3, we had a plus b and a plus b. In 2, we have x plus 4 and x plus 4. In 3, we had x minus 2 and x minus 2. In 4, we have y plus 2 and 2 plus y. Are those the same things? Is y plus 2 the same as 2 plus y? Yes. Okay? Y plus 2 is the same as 2 plus y. Think about, when you add, right, doesn't it make sense? Isn't 4 plus 3 the same thing as 3 plus 4, right? They both make 7. Y plus 2 is the same as 2 plus y. So in other words, we can factor this out one more step here. Okay, so Matt, do you want to do that for us too? So we can take out this y plus 2 from each. And then Matt, what will be left behind from here if I take out the y plus 2? 2y, and then what will be left from here? What will be left here? 3x. Okay, and then that is fully factored. Psych nah. Okay. Question number 4. So that is our ultimate goal, being able to do something like number 4 here with a factor by grouping. Okay? So. What's that? Yeah, sure. All right, Liv. Here we go. Liv has requested to do this next one. So this one's going to be a little bit tricky with all the subtractions, but we'll go with it here. Okay, so again, put your grouping symbols around your parts here. All right, the first set right here, Liv, what can we factor out from here?
14.
A 14, very good. Okay, 28 divided by 14 is going to give us,
2 minus q.
okay, 2, very good, minus q, just like that. So take out the 14 from 28, you're left with a 2. Take out the 14 from 14q, you're left with a minus q.
Minus 2q.
And what are we going to factor out from here?
Minus 2q.
Not a minus 2q.
Negative 2.
Well, does this have a 2?
Oh, so just negative. What?
So this does not have a 2, right?
No.
So we can't take a 2 out because that one has, but that one doesn't have anything that we can divide by 2. So just a q. Yeah, so we're going to factor, and we'll factor out a minus q though. That's right. We do want to factor out a minus q. And so negative 2q divided by negative q is just going to be positive 2 now. And then what's going to be here?
Plus q.
It'll be minus q. Yeah, that one's a bit tricky here because we're taking out a negative q from the negative 2q, so we're left with just a 2. Because again, we're dividing this negative by a negative, so it becomes positive.
Oh, no, I didn't mess up. I did it like this. I did that one first, and then I kept it the same, and on the second one.
Oh, okay, I got you.
So I was
Okay,
doing first
okay,
and third.
I got you. So but you have this then, okay. And so that's the right idea, right? But we do have one more thing, that 2 minus q is in common to both there, and so we can take that out, and then what's going to be left behind here?
And then the next parentheses is going to be 14 minus q.
14 minus q, the leftovers there. Exactly right. And so there's our final answer. Okay. All right, let's do one more here together. I'm going to have you guys try one. Sky, question?
I want to do it.
You want to do it? Okay. That's a statement, but I'll allow it. Okay, here we go. So let me group them together. Again, first 2, second 2. Sky, from the first grouping here, what can we take out?
5y.
5y. And what's left behind when we do that?
Y and 5.
Y plus 5. Exactly right. Okay, how about from here, Sky, what can we take out?
-3.
Good. Negative 3 is what we want to take out there. So negative 3, and then what will be left behind? Negative 3y divided by negative 3 is,
Negative y, or it
it would be positive because you're doing negative divided by negative, so it becomes positive y. And then negative 15 divided by negative 3? Positive 5. And again, you see, we have those y plus 5s in common, so we'll have y plus 5, parentheses, and then what's going to be left over? So if I take a y plus 5 out of here, Sky, what's going to be left?
5y and
Yeah, 5y minus 3, like that. And there's our final answer. Okay, so there it is factored. All right, so flip those papers over. I'll leave it up, okay? Flip those papers over, please. I'd like you to try, let's see here, number 8. And 8 and 11, please. 8 and 11. I know that's like a weird combination there, okay? But try 8 and 11. I'm going to leave this one up so you can kind of see it. But try number 8, try number 11. If you've already finished number 8 and 11, review them, check over them, make sure you got them, you got them right.
Wait, do which one?
8 and 11. Here, I'm going to put it up on the board. 8 and 11, please. 8 and 11, please. Okay, so number 8 and 11, give those a try right now. Try 8 and 11 on the back of your paper there. All right, go ahead and try 8 and 11. I'm leaving up number 6 so you can see that one to help guide you, okay? So remember, you need to add parentheses in here.
That's what it was, yeah. No, we already did it.
Okay. Yeah, go ahead since you got it. Yeah, go ahead. You can go once you finish the problems. Yes. You don't need to go when she's comes back. You can go after you finish the problems there, and I'll take a look at it. Okay, gentlemen. Oh, good job, Mark. Okay.
Ben, will you finish these two, 8 and 11? Yeah, 8 and 11.
Thank you for getting it done. Ray, doing okay on this stuff?
I think so.
Okay, how are you doing okay? Sit down. Laura, right? And you? Yep. So Max, your pencil real quick. So first things first, right? We're told that we're doing factoring by grouping. You want a group, okay? So let's make some groups. Right there. So now only consider this first group here. Okay, I see that we have a 2 and a 12. I can divide both of those by 2. So I'll
Have you
2.
finished 8 and 11?
But I also see they both have a p. So we'll take out 2 and p. Okay? If I take a 2p out of 2p squared, I'll have a p left over. If I take a 2p out of 12p, I will have a 6. 12 divided by 2 is 6. P divided by p, what's gone? Okay? And then here, what can I take out? These both divide by 3. So I'll take a 3 out.
But they like to do
Taking a 3 out of here leaves me with a p.
smashing up
Taking
small
the 3 out of here will be minus 6.
Yeah.
They both now have p minus 6.
No, I'm
Further
so
take that out.
I do know about that.
And I'm left with 2p minus 6. When I take those out. That's done. Okay?
Can you like do this
We are
please
going
to show us how to do it? Can you do it now?
Yeah, 1 second again.
Okay, then we can help.
Mine good?
So, do you know, so look,
I like
let's
to
do
take
these
the 2p
here.
minus 6 out. But what happened to the 2p and the plus 3?
And then
That should be a
factor-
2p. Oh, I see what you did. You put it kind of like reverse. Is that a 2p? Okay, I see what you did. That's okay.
But the greatest common
That's strange that you
factor.
put the order on there, but that's okay. And then you
So
want to
for
do that.
okay, so what's the same with both of
What are we
these?
doing here?
2p squared and 2 and 12p.
I know. So, okay, Max, you're
You would take the 2p out, right?
So,
What would be left
you
here?
took a 4 out of here, and that was good. That does
What
give you
would be
this.
left here? 2p.
Okay, but this is your eraser.
No, so if we take 2p out of this, what's left? What's 12p divided by 2? Yeah, 6. Is that factored?
Okay,
Is
we
that-
look
is
back
that
inside
combined?
here, Catherine. I see both of these
What
have
can you do over
b's.
here?
So I'm going to take
2p
out
minus
b
18.
squared.
What can you take out? The 3, because we don't have a p over here.
Okay? If I take a b squared out of that, I'll have just a b to the 1 or d. If I take the b squared out of that, it's
P
gone.
minus what's 3? No, it's a
Okay?
squared divided by
Then I look here. I took a minus 5 out.
6. So see what we've done? 2p times p is 2p squared. Minus
That's great.
2p
That minus
times
5
6 is
minus 5 is coming out of here, right?
So we have factored
divide
this.
this by negative
Is
5
this
is
and this the
positive
same?
v, not v to the third. Yeah.
So
Dividing
what
this by negative 5 gives you
minus
negative 3.
6
No b squared, that's just minus 3.
times,
Now
what do we
you
have
see,
left?
if I bring it down here one step,
Plus
factor that b minus 1
this,
out.
these two are factors. That's this, factor one.
Take b minus 3 out, we'll have 4b squared minus 5.
Try that, eleven's kind of tricky, but you try.
You're always on top.
Okay, here we go. Yeah, go ahead. All right, here we go, number 8. Here's number 8. Okay, p minus 6 times 2p plus 3.
So, like, for mine, I just did 3 plus 2p. Do you have to do the 2p plus the 3? Like, because
You got to this point, you're saying?
yeah, like, you have to do it in order. Like, you have to do the one that you did first and then the second one.
Oh, did you have 2p plus 3 first and then the p minus 6?
No, like, I had the 3 plus 2p. I didn't know if you wanted it to be like.
Oh, I see. I see. So you have, instead of 2p plus 3, you have 3 plus 2p. That's okay. That's okay, I would say. Yes, that's okay. Yep, Kendall. Yeah, go ahead. All right, number 11. There's number 11. Oh, number 8? Here. So 2p squared and 12p, 2 and 12 both divide by 2. So I can take a 2 out. But then the p squared and the p, that means there's one p that's in common there, that's shared. So I'm going to take that one, so it's a 2 and a p that can both come out of both of these. Okay? And then here, there's only a p, there's no p there, so I can't take a p out, but both 3 and 18, negative 18, I can divide a 3. Those are both divided by 3. Okay? How to get this? Down here? So then, once I factored by the grouping, I see, oh, wait a minute, what's left over? They both have a p minus 6 left over. So I further factored. I factored again. I pulled the p minus 6 out front here, leaving behind the 2p and the plus 3. You see it? I took out the p minus 6 and this p minus 6. I took it out right here. And then I'm left with the 2p plus 3.
Oh, all right.
Okay?
All right, so that's one factor.
All right, and then there's number 11. There's number 11. Questions on that? Tyler.
Yes. Okay. So we divide 4v3 by v by 12v2, correct?
You are looking for what you can divide both terms by.
Oh.
It's the GCF. We're doing GCF of this first group. And then we do the GCF of this second group.
You can divide them by 3.
Okay?
You did 4 and then 5. We divide them both by 3. Right?
Say it one more time, sorry.
So if you can divide both of them by 3. Negative 12 and positive 15. You divide them by 3 and you get.
True, but they're not grouped together. Right? They're not grouped together. The 12b squared is grouped together with the 4b cubed. So we're only going to look for things in common between these two terms. And then the negative 5b and the 15, those are also grouped together. So we're only going to look for common factors between those two terms. Do you see what I'm saying now? So yes, you're right, Tyler. You could combine, you can do different combinations, and you might get different things that factor out. But we want to have it in standard form, and then you group the first two things, group the second two things, and then you can factor stuff out. Okay? That's how we are going to do factor by grouping. All right. So, do we need to do another example of this, or are we ready to move on? Move on? All right, here we go then. Okay, so here's what we're going to be doing. Okay.
You don't want to look at the homework that they did yesterday at all, or that paper? That's fine.
I might hold off and do that tomorrow maybe or something like that.
So hold on to this homework.
Just
that
because
I
we're on
handed
a
out.
bit of a roll here maybe. I don't
That's
know.
fine. I just,
I'm gonna take
someone
my pass
else,
it on
they
from
could
here
throw
to
it
here.
away, so I just wanted to answer that
No,
question.
that's true, Miss Mulcahy, that's very true.
What we're gonna do, looks like we're gonna go to tomorrow. So hold on to all of those things.
You're welcome. Well, I am not sure. We're going to start at 1. We're not going to go all the way.
You give it a
They're
general.
similar, I know, right? They don't quite look the same, do they?
Are we just gonna do like the font? Or
There are
like
3 terms, right? Matt, hang on, bud, because there's some. You're not ready to move on with these just yet, okay? I promise you, you're not there yet, okay? I'll cut you loose here when I can, but you're gonna have to wait, okay? I like your enthusiasm, but I wanted you to be ready for them. Okay, so how does this problem? Let's look at number 1, and again, the directions are factor each expression completely. So the directions in these problems aren't super helpful, right? If you remember back in the warm-up, we can use that word simplify to mean a lot of different things, right? When you see the word simplify, it can mean add, it can mean subtract, it can mean multiply, whatever kind of operation you see. Here, when we hear that word factor, it can mean a lot of different things, okay? So sometimes that means we're going to use GCF. Sometimes that means factor by grouping, okay? And that kind of thing. When it comes to factoring a trinomial, like in this form here, okay? When it comes to factoring a trinomial in this form, we're going to use factoring by GCF first. So let's look here. Do we have a GCF that we can factor out here? Is there a number that divides both 6, 19, and 15? No. 19's prime. 6, if it was just 6 and 15, we could do 3, but that 19 is not divisible by 3. Can we factor an x out of all 3 of these terms? No. So there's no GCF, so like check. There's no GCF. We looked. Okay, there's no GCF, so we're going to move on. The next thing we're going to try and do is factor by grouping. But what's different about this problem than other factoring by grouping problems that we've done? Let me just pull up the previous one that we were talking about, right? Yeah, okay, we have an odd number of terms. 1, 2, 3. Right here, every time we do factor by grouping, how many terms do we have in factor by grouping? 2 pairs, but 4 total, right? We start with 4. So looking at this, right? How are we supposed to group it? Are we supposed to do the first two and then leave the last one? Or are we supposed to do the last two and leave the first one? And the answer is neither of those. Yeah. Do you have it? Well, go ahead.
I have it.
Okay, what do you think we should do?
You can make it 6x to the power of the second plus 10 plus 9, plus 10x plus 9x.
Okay. So,
Can you do that?
yeah, okay. So,
10x plus
like this, you said?
yeah, plus 15.
Okay. So let's look at what Liv said to do here. Is this good math?
No.
Is this equal to? Sorry, let me say this. Is this the same as this? Are these saying the same thing?
No,
But
they're
it's
not.
gonna give you the same.
Are they equivalent to each other?
Yes.
Yes. 10 plus 9 makes 19. Mark and Dylan, pay attention. Okay? 10 and 9 do add to make 19 here. And so we can kind of break these up like this. Now,
And you can add them back together because you can use it.
right, we can combine like terms, but we don't want to do that here. So let's take a look here. Now that Liv broke this up this way, let's group them here. Okay? Those first two terms, is there a GCF that we can factor out? Yes, what can we factor out from these two terms? A 2, right? They both are divisible by 2, and an x. So we'll do 2x, and that leaves behind a 3x plus 5. And then what can we factor out from here? A 3, right? Shh. A 3 factors out, and what will be left behind? Well, careful. 9x divided by 3 is 3x, and then a 5, yeah. And then would you look at that?
And then
3x plus 5, 3x plus 5. They're the same, aren't they?
So I did it right.
What if the second or first or just one of the terms that are like parentheses that you make can't be like you can't get it in.
Right. So how are we supposed to know? So Liv, I don't want to say like guessed, but I mean you guessed kind of correctly there. Because I mean, is 10 plus 9 the only way to make 19? No. Liv could have said 11 and 8, or she could have said 5 and 14. And if we had done those, Caden, we would have been stuck, right? That would have been wrong. And Caden's like thinking about all the different combinations that add to 19. He's like, if I'm a bad guesser, it's going to take, he's probably not thinking this, but if you guys are bad guessers, like unlike Liv was there, if you're bad guessers, you're going to be in trouble trying to figure out all these different numbers that how are you supposed to figure out which ones work and which ones don't. So let me show you a way to do this, to kind of like reduce the number of guesses you have to take and stuff like that. So I'm going to skip number 2 for right now, and we'll go down to, I'm trying to make this a little bit easier, but these numbers are kind of big. Let's go to number 3. We'll just do that one. Okay? So if we're not able to guess like Liv did, and Liv, that was a great job there, good job. Okay? What we can do is this instead. We're going to take our lead coefficient and multiply it with our constant. Okay? So take your lead coefficient to 8 and multiply it with 15. Okay? So what is 8 times 15? Anyone know? That's 120. Okay? And so that 120, what we're going to look for are two numbers that multiply to 120 but add to 62. That is going to be the key kind of like step we take here, Caden, so that you don't really have to guess about how to break up the 62. Okay? So we need two numbers that multiply to 120 but add to 62. Oops, I'm off the screen a little bit there. Okay?
That one would have been harder. The first one was easy because just like I would think
The first one's
number first. So
right.
10.
No, that's good. That's great.
This one I would have failed.
Right, exactly. No, but that's great, Liv. You did a great job there. I've never seen a student in my entire teaching career come up with something like that off the top of their head so quick. So it was a good guess, whatever it happened to be. But, that was great. That was really cool. Okay? I mean, I wish I had set that up because that was such a good segue.
Should be.
But back on track here. So, let's think. What are some ways to multiply to get 120? Well, I could do the easy way. I could do 1 and 120. Can I divide 120 by 2?
Yes.
It's
Possibly.
2 and
60.
60. Let's keep going here. What about like 3? Can you divide 120 by 3?
30.
40. 3 and 30 is 90. All right. Alex, 12 divided by 3 is 4. So 120 divided by 3 will be 40. 40. Yes. 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 Okay,
I'm
so
just going down by scale.
Yeah.
At first. Thank you.
what about 4?
20.
And 30. Okay. 5. This is a little bit harder, 24. You guys will be able to use your calculators, of course, for this. Now, I could keep going here, but I'm going to actually stop because we already have our answer.
It's 24.
So again, we're looking for two numbers that multiply to the 120. Well, here, these all multiply to 120. But which of them add to 62?
24.
5 and 24 adds to 62?
2 and 6.
Add to 62. Yeah, the 2 and the 60 here. Okay, so there's our pair. So then we make the 8y squared plus... Now, should I put the 2 and then the 60, or the 60 and then the 2? And the answer is, it won't matter. It won't matter. In the end, it won't matter. A few of your intermediate steps are going to be different, but otherwise it'll be the same thing. So I'm going to go ahead and just do the 60y plus the 2y plus the 15 there. Okay, but you could have done the 2y here, the 60y here, your choice. Okay, now, this is what Liv did, kind of mentally. Okay, she kind of like guessed and got it right, almost, maybe. I don't know. Is that what we would say? You guessed and got it right, pretty much? Okay, so Liv guessed and got it right.
So I just did 10 and 9, so it
Yeah.
would be even.
Yeah, that makes sense. I got you. Cool. But now we're going to group these first two terms, and we'll group these second two terms. Okay, from the first group there, Mark, can we divide anything? What number divides both 8 and 60?
8.
I don't think 60 divides evenly by 8. It does not.
4.
4 does. 4 does. So let's pull a 4 out. Okay, and what else can we take out of here, Mark? Besides the numbers, they both have a what in common?
They both have a y.
A y. So then that leaves us with 2y plus 15 here. Plus, oh my gosh, there it is. Is there anything we can take out of 2y and plus 15?
No, sir.
No, so I'll put a 1 in front there just for our, benefit, because we know there's a 1 there too. Okay. And look, they both have a 2y plus 15 in common. Okay. Right, Alex? So 2y plus 15 times, well, if I take the 2y plus 15, what's going to be left?
4y plus 1.
There you go, Carson. Exactly right. 4y plus 1. And there's our final answer.
Takes a little bit of thinking.
It's a lot of work, but here's the thing, guys. The way I was taught how to do this, guessing and checking. Okay? Guessing and checking. So we're teaching it to you, I would say, the easier way here, by doing it this way. There's less guessing and checking. Yes, it takes some work, but there's less guessing and checking. All right, let's jump over to number 4, and then I'll have you guys try one on your own here. The homework, I'm not sure, but I'm going to at least have us try numbers 7, 10, and 12 there, Matt. So if you want to give those a try, jump ahead. All right, let's look at number 4. How do I know which one I want you to do? Right, I'm going to show you. I want you to use the second one, Carson. Liv's not wrong, but it's just like our method's a little bit easier to do. You don't have to just be able to see it. It's like 7, 10, and 12. I think is what I said. We're looking at number 4. Number 4. Let's see number 4 together here, folks. Number 4. Okay, so again, what's our lead coefficient in number 4?
3x2.
Okay, just the coefficient is 3, and then times our constant, or our last term here, is 24. So 3 times 24 is 72. Okay, so I need two numbers that multiply to 72, but are going to add to what? 22. Okay, so let's think here. I could do 1 and 72, but those don't add up to 22. I could do 2 and 36, but those don't add to 22. Let's try 3 and what? let's see, 72 divided by 72 divided by 3 is 24? Yeah, 24. Thank you. But those don't add to 22. We have to keep going here. Does 72 divide by 4? Yes, it's 4 and 9. Whoop, no, not 4 and 9, sorry. 4 and 12? No, 4 and 18. Thank you, sorry. Sorry about that, folks. Brain fart there. Massive brain fart. Are we done?
No, sir.
What's 4? Okay, we're not done with the work, but I mean, we found our pair, right? 4 and 18. They add to 22, so that's our answer. Okay, so we're going to take that 3x squared. The 22x, we're going to make it 4x plus 18x plus 24, like that. So break up that 22 into the 4x plus 18x there. Okay, just like Liv said we were supposed to do there. Break it up. Okay, so let's go to Catherine. Catherine, we're going to group here. What can I take out that's in common between these two right here? Okay, does 4 divide by 3 evenly? It doesn't. So actually 3 and 4, there's no number we can take out there, but what about the x's? How many x's can we take out? Just an x. Yeah, so we'll pull one x out, and that leaves us with 3x plus 4. Okay, plus, and then we need two numbers that divide. Can we divide? Let's see, is there a GCF there? I'm going to go to Matt S. Matt, do you know something? A number that divides 18 and 24? 6. So we pull that 6 out. Well, what are we left with, Matt? If I do 18x divided by 6, what does that give us? 18 divide out of 6. What's left?
Are you writing this down?
3x. And what about 24 divide out of 6? 4. Okay. There's the 3x plus 4 in common there. We'll factor the 3x plus 4 out. Okay. And then what will be left in this set of parentheses? Let's have you do it again, Matt. So if we factor out the 3x plus 4, what's going to be left from this if I take out that 3x plus 4? Just the x. If I take out 3x plus 4 from here, what's left? So plus 6. And there's our answer. Okay. So, what's that?
I was saying we try one with one.
Yeah. So go ahead now. I'd like you to go ahead and try 7. All right, number 7 there, please. Number 7. Let's give that one a try. Okay? And I'll try, let's see, can I fit? Okay, try number 7, and I'll just zoom in on number 4 here, okay? Okay, so there's number 4 to help you, but try number 7. Try number 7 now. Number 7. Now you'll notice I'm skipping some of the problems in here because some of them have subtraction. I don't have to worry about those for right now. We're just going to worry about all the positive ones right now. So try number 7.
Wait, for number 3, how did you get 120? Where did you pull that from?
It's the lead coefficient times the constant, so 8 times 15 there from the problem.
And so it would be 3 times 20.
So for 7, we would get...
For 4, it was 3 times 24 to get the 72. So in 7, you're going to do what times what?
10x.
Just 10 times the 14 to get your 140. And then, Alex, you're looking for two numbers that multiply to 140 but add to 39.
140.
Is there any other problems you have?
Nope. And then factor by grouping.
He's eating the worst song.
Yeah, do 10 and 12 on the back.
He's trying to encourage something.
That'll be the homework is on the back.
He's trying to say nothing.
So again? Close, 5 more minutes. Time flies when you're having fun, Simon.
It's fun, but... How is it? No. I think what happened is the other day when we took you second chance,
Shouldn't be, no. It should only be nice numbers. We don't want to use fractions. No decimals or anything like that.
It's
Making more sense now, huh?
Yeah. What was it?
10 and 12.
And you don't know homework for tomorrow?
No, I don't. It might be some more from this paper. I'm not sure. What's that?
Any classroom?
It would probably just be some more stuff like this. So I say just check out hold on to that paper and then check it out for tomorrow.
This is what I got. This is what mine.
Okay, so yes, 1 times 140 gives you 140, and 2 times 70 gives you 140. But the problem is they have to add to 39. So this does not add to 39. This does not add to 39.
What do you mean? Like the numbers have to equal 39?
The numbers you pick. So like for example, I did 140, right? I did 1 and 140, 2 and 70, just like you did. But then I saw, oh wait, 4 and 35. That is what adds to make that 39.
And then 4 groups of 35.
And
is
so
equivalent to.
So then hang on. So then you do, 10x squared plus 35x plus 4x plus 14, and then you group the first two.
We have a
the second
test
two.
tomorrow, right?
No,
Quiz?
no,
No?
no,
We usually have one on Fridays.
no, no. Okay,
Can
but I
we
do want
miss
you to
that
know this.
anyways?
Oh, I don't know if we're gonna have that, but if we do, then yes. I'll
Oh,
put
there's a
you in.
half day?
It's a, I think it's gonna be a shortened blocks because of the volleyball game at the end of the day. I think.
Oh, so can I leave? Did the buses come early or later?
No, it'd be normal time.
I thought the volleyball game was only if you pay like money.
It is, but Miss,
Do you have to
I feel
watch
like they
it?
don't they shorten the schedule, Miss Mulcahy? I forgot if they did. So if we have set, they don't. Okay, well then, if we have set, I'll pull you in.
Okay, thank you.
Did you pay your money, Dylan? No.
I paid for him. He hasn't paid me back.
Mark, that was your first mistake. I do too.
Wait, all we do is number
10 and 12.
7?
7, but then do 10 and 12 for homework. Okay, folks, real quick. Here's number 7. Let me talk it through here with you. Okay? 10 times 14 is 140. You then want to look at pairs of numbers that multiply to 140. And again, I just start with 1 and do 1 and 140. And then I look at 2. And 2 does divide it. It's 270. And then 3 doesn't work. But then 4 and 35 work. They give you nice numbers. And in fact, that's the answer because 4 plus 35 is 39. So break that 39 into 4x and 35x. Group and group. Okay? Take 2x out of the first two. Leave with 5x plus 2. Take 7. Take 7 out of this. 5x plus 2. They both have a 5x plus 2. So you're left with 5x plus 2 and 2x plus 7. Okay? And there's your final answer. Questions on number 7. Okay. Your homework is 10 and 12 on the back. 10 and 12 on the back. Okay. If you get stuck, go to YouTube, go to our Google Classroom and watch the YouTube video that I'm going to post, okay? Go back and rewatch it. You can get it. Sometimes you just got to see it more than once, okay? Or twice or 3 times. You get it? All right.